guys can watch it and refer it when you practice. So, okay. So, coming to DevOps. So, DevOps, before going deep into that, previously, we have a software development life cycle. So in that software development life cycle, we have the most popular modules that we were using and still we are following is first one is a waterfall model, and the second one is agile model. So these two are the main popular models that we currently follow, and waterfall model is an outdated model. As there are some drawbacks in that, so that will be discussing very soon now. So let's straight away dive into it. Okay, so coming to the waterfall model. So let me be very clear with you. So like when you plan to design an application, software application, what you do is you first thing is you gather the requirements from your client, and second the second part is you design a system. So you design the modules. So what modules you'll be using and what are the programming language you'll use in that, and so how do you design your UI, and what modules you'll be including in your UI. So all this comes in the system design phase, and then you implement your system implementation. So this phase is a coding phase. So you code, you prepare your code, you write your code. So all the developers, they write their code and they test it. If the functionality of the code is working properly or not, they test the code, and later they will deploy the code to the users, or they deliver the code to the client. So this process is the waterfall model. So the main drawback with this is once you complete the first phase, then only you can go on to the next phase. So the delivery process of the software to the client is much more delayed. So that's the main drawback of this process. So that's why this is the old model. So current current companies are not following this model. So mainly we are following is agile model. Agile is a software development in an umbrella term. Like it consists a set of methods and practices based on the values and principles exposed in Agile Manifesto. So basically, these are done in sprints. So you gather the requirement from the client, you set up a sprint planning, and you plan your sprint, and in that sprint you distribute the works. You distribute your work to a developer. So each developer work on a particular task, and that task is one sprint. So once you complete that task, the task is immediately tested, and if there are any bugs, if they find any bugs in that task, again it will go to review, and again the developer will fix the task and he will deliver the software. So this process is a much more faster process compared to a waterfall model. So I hope you guys understood the agile model and waterfall model. Can I can I have a confirmation? Thank you. And now, so DevOps. So what is DevOps actually? DevOps is not a tool. DevOps is not a software. So DevOps is a methodology or a practice. So before DevOps, like the developer used to develop the code, and he used to send it to the operation team, and the operation people used to deploy the code onto the servers. Like they were like a gap between a development team and an operation team. So the developer used to complain that, hey, look, the code is working fine in my local laptop, in my local machine, but in the production server it's not working. So he used to they used to complain on the operations team, but the operation people, they would say that, hey, look, the server and the server is up and running, the network is good, so there is something problem with your code. You need to fix your code. So like it created a gap between developers and operation team. So this gap led to the delay of the software application to the end client. So then DevOps came into the picture. So DevOps is nothing but it is an integration of two teams, development and operation team. So both combined together is called DevOps. So DevOps, here in the slide, it's clearly mentioned that DevOps is a term working together to bring developers and operation people closer to collaborate smoothly. So there are different tools to automate your software. So DevOps uses different tools. It uses scripts to automate. It uses different tools like in that automation process, you also include testing or automation testing. Everything is included in that, and you also have continuous integration and continuous delivery. So these topics will dive deep into it in the coming slides. So here, agile and DevOps. So agile and DevOps is a perfect combination for a software delivery. So you prepare your you gather your requirements and you work you place the work to the developer in agile model, and the developer pushes the code to a source code repository, and from there the DevOps takes place, and the DevOps people, the DevOps team, they create pipelines. So they automate the pipelines, which will have a complete flow until the delivery and monitoring. So here is DevOps is not a specific tool or technology, as I told you, and just for DevOps is not only just for developers and operations. It is a combination, and the people work, the developers and the operation team, they work together and they implement the process, which is called as DevOps. So it is not a replacement for ITIL or Agile. ITIL is information technology and infrastructure libraries, or Agile. It is not anything a replacement for that, or it is not anything new to Agile. So only about automation. It is not only about automation, and it is not only a set of practice. It includes a culture. It is a cultural shift. Okay, and as an instant solution, it is not an instant solution. If you previously, if you observe, like there is a configuration management tool in Puppet, which is Puppet. So New York Stock Exchange, they use Puppet. Okay, and all the servers, there were like 150 servers which were working, and they deployed a new version of their software application onto those servers, and the next day those 150 servers didn't work. So everything was crashed. So due to Puppet, they used a tool. Due to Puppet, the Puppet has a rollback capacity, so you can roll back your release version to the previous version. So using Puppet, they actually roll back those a new version to a old previous version, and they were able to save billions of dollars. Okay. And next is the stakeholders who are involved in DevOps. So DevOps, we as a DevOps team, we involve or we communicate with the stakeholders. So we communicate with architects, business representatives, customers, product managers, project managers, product managers, quality QA and QC quality analysts or test engineers. And you also communicate with system engineers, system administrators, information security, IT operation engineers, release engineers, database admins, network engineers, support professionals, and suppliers. So all these teams, they collaborate and they interact with the DevOps people, and they work. They make the flow go smooth and easy. So, any questions, guys, so far?
No.
So, the characteristics of DevOps: treating infrastructure and code as the same thing, like it's the same software. Treating it as the same software. Okay, the software is built and deployed to achieve a faster cycle. So when a developer makes any change, or when a developer commits his code onto a source code repository, so you guys may be unfamiliar with these words like source code repository, version control, like build phase, or like all these phases. So please bear with me in the coming slides. Will be and clear all your thoughts. So so before going to this slide, from maybe I'll take you to a good understanding. All right. So here you see. So here, this is the actual DevOps workflow. So the business needs and use cases. So the what the product owner does is he goes to the client, he takes all the business requirements or business needs or the use cases, and he set up a meeting with the software development team, and he gives all the feedback from the client. Okay, the software development team, based on the requirements, they develop the code. So once they develop the code, then they will check into a source code repository. Git is a source code or version control repository. So here, the developers check in their code, and once the code is checked in, so we have enabled DevOps. So what it does is it picks up a pipeline, Jenkins pipeline, and it builds your software. So in that build process, what it does is it creates binaries and libraries for your software, and it create a package of your software, and that package will be delivered to a repository, like a image repository, or that package will be delivered to a artifactory. Artifactory is nothing but it's a storage. It's a storage unit of your predefined binaries and libraries of your code. So once your code is moved to the artifactory repository, so this is done in like it's done in two process. So the code is moved to artifactory repository, and automatically there are several test cases, Selenium test cases, which will be run. Okay. So once that's done, once that completes, so here you can use Chef or Puppet as deployment tool. So Chef or Puppet, it will pull the code from the Artifactory repository and it will deploy onto your cloud or your on-premise servers. So once the code is deployed onto the on-premise servers, then you need to monitor your code. Like if there are any issues or like if there is any CPU usage, is it's exceeding the CPU, the memory is more, the consume more or whatever, or if there are any threats or if there are any failures in the pod or the container is failed or the image is failed. So it will monitor. You have a couple of monitoring tools like Nagios. So it will detect all those changes and it will send it to Jenkins. It will send that alert to Jenkins, and the Jenkins, what the Jenkins does is Jenkins will send those alerts to the developers. If there is any emergency alerts or if there is any failure, it will send those alerts to the developers. So any doubts in this, guys? So I want to make this session as an interactive session. So if you have any doubt, please go ahead. Any questions?
No, no question. No.
So is it okay? Can you guys send any questions? Arun, Abhijit, Omji, or Robin, Linto?
No, you can continue.
No, continue, please. No questions.
No questions? All good? All right.
Yes.
So this is like an infinite process. So DevOps is like an infinite process. So here you plan your you gather your requirement, you plan for your software development, and you develop the code. And once the code is developed, you build the code. So the reason you build the code is to create a package of your binaries and libraries. So once you do that, you test your code, and once the test is complete, you push the code to a Nexus repository or the Artifactory repository. Nexus is a tool, or it's similar to Artifactory repository. Nexus, JFrog, all these are the Artifactory repository. In the next coming slides, I'll show you with the clear pictures of the tools that we'll be using in DevOps. So once the code is pushed and to a release, and the code is deployed, and again the code is operated. Like here, this is all the deployment phase. Once this phase is complete, and then it again goes to monitoring. So here in this slide, this is a clear example. So in the planning and code phase, you gather the requirements, you plan your code, you plan your application, software application, and then developers will write the code and they will push it to a source code repository. So source code repository, it might be Jira, it might be Git, or it might be Subversion. So any one of you have any idea on these tools so far? Or anyone of you use these tools?
Yes. Are you able to hear me?
Yeah.
Yeah. Yes. Here we are using Git over ADO.
Okay, Azure Git, right?
Yes.
Okay. Azure Git, GitLab, or GitHub, it's all similar. So it's a source code repository. So the developers push their code into the source code repository, and once the code is being pushed to the source code repository, and then it will go to a build phase. So in this build, you have like different build tools available. So mostly for Java-based application, it depends upon the application you use, the build tool you use. So if you are using Java application, we use generally people use Maven, or Gradle, and like if there is an MS build, Microsoft build, or if it's a .NET, we use Microsoft build. And once that's complete, it goes to a testing phase. Here you create a JUnit test. Here you create unit test. So tests are like two types. One is functional testing, and the second one is regression testing. So functional testing and regression testing will continue in the next upcoming slides regarding it. So here you guys just understand that after the build phase, there will be a testing phase. So in the testing phase, we can use the tools like Selenium or JUnit to test your unit test. And once this is done, so this is integrated using Jenkins, or you can also use Hudson or Bamboo. So these three are the integration tools which will integrate your software, the software that's being developed by the developer. So here, if you see these four phases, so these phases are being developed by the developer, and this is being maintained by the operations team or the infrastructure team. So the combination of this is integration. So the integration is done through Jenkins. So once the tests are done, the code is being integrated and it will be pushed to a Artifactory repository. So Artifactory repository might be Nexus repository, or it might be JFrog, or if you are using Azure DevOps, it might be your container, Azure Container Registry. Abhijit, since you said that you are using Azure DevOps, so like, do you have any understanding on Azure Container Registries?
Actually, we are using only the Git part and boards of Azure. Rest we are doing on our on-prem infra.
Okay, so how are you doing your integration part? So are you building your pipelines in Azure DevOps, or like you are using some
No,
other different
Jenkins.
tool? Jenkins, okay.
Jenkins.
Okay,
And Jenkins is running on our on-prem infra.
okay, okay. All right. So so this phase is done. Once this phase is complete, then it goes to a deployment phase. So we have like containerization tools like Docker, and or container orchestration tool is Kubernetes. So you can deploy it through Kubernetes, or once you package it into a container, and then you can use this tools like Chef or Ansible. So these two are the major used deployment. All right. So we are right here. So once the test phase is complete, then with the help of Jenkins, we'll integrate the code, and we'll move it to a test repository, and we'll deploy it using Chef and Ansible. So these Chef and Ansible are the two majorly used tools for deployment, and you can also use Puppet for that. So once your deployment is complete, then for the monitoring part, you'll be using Nagios, Splunk, ELK Stack, or Prometheus. So for logging, these are the monitoring tools. So it will monitor your cluster health. It will monitor your pods. It will monitor your Kubernetes pods. It will monitor for your the CPU usage, and it will monitor the cluster usage. It will monitor the nodes, the node health of your cluster, and all that stuff. So once the monitoring phase is done, or if there is any issues, it will trigger to the Jenkins, It will send an alert to the Jenkins, and with the help of Jenkins, we can set up a email notification to the respective teams. So this is the issue, and they can work on that issue and they will fix it. So all this process, and once the monitoring process is complete, and it again goes back to a plan phase. So this is like an infinite process. So this is much more easier process, and it delivers your software much more easily, and it mainly focus on the software agility and stability. So software agility and software stability is much more important for a good software application. So this is a basic understanding of like what DevOps is, and what actually the tools that you'll be including to perform a DevOps activity. So here this is the pipeline phase. So here this is the version it will build, and if the build fails, if the build of the software, if the build of your code fails, it will with the help of Jenkins, you can also trigger an alert, and it will roll back to a source code version. So this will be again informed to the developers, and the developers can work on it, and they will check in the code. And once that phase is complete, then prepare automations. So all these phases are like revertible phases, or all these phases are like it's a loop phase. So this is called a deployment pipeline. So in deployment, you will have like continuous integration and continuous delivery. So this is these are the interview questions. So when you go for a DevOps interview, they will ask you what is continuous integration, what is continuous delivery, and what is continuous deployment. So continuous delivery and continuous deployment, it's one and the same, but there is a small slight difference. In that, I'll quickly explain you what it is. So now coming to a continuous integration. So continuous integration is nothing but, so once your code is built, it is moved to a different it is moved to a next phase, right? So these phases, so all these phases, it's done continuously, and it's been integrated. So each phase is integrated with one another. So all these phase combination together is called as continuous integration. Okay, and continuous delivery. So once the continuous integration is done, and it will deliver your software. So this is done in an infinite way. So this is called a continuous delivery. So here you'll have like continuous delivery and continuous deployment. So continuous delivery is a manual process. So continuous deployment is an automated process. So in your production environment, you always use continuous delivery, not continuous deployment. So continuous deployment is used in it is used until a UAT stage or a stage environment. So in your production environment, you always use continuous delivery, because once the software is tested, and it will be deployed onto your test servers, and you'll run your post deployment stages. So here you cannot deploy a test or a test version of your software application onto a production environment, because if you do that in real time, it will break your production environment. So this here you'll have a manual approval. So this creates a release. So this is the release. So so the release people they perform this activity on a software release. So once the code is being pushed to the Artifactory repository, and they'll pull the code from the Artifactory repository, they will manually approve the deployment, and using those manual approvals, with the help of the tools like Chef, Puppet, or Ansible, you deploy your code onto your servers. you deploy your code onto your on-premise servers, or you deploy it onto a cloud service. So are you guys clear so far?
Yes.
And these are the Jenkins.
Yes, it is.
Yeah, you're saying something?
No, it is cleared.
It's clear. And yeah, you all are always welcome. If you have any doubts, please please go ahead. All clear? Can I proceed with the slide?
Yes, you can
Yes.
proceed.
All right. So here, these are the tools that we have recently discussed. So all these slides and everything, all this recording, I'll upload it onto a YouTube channel. So I have a YouTube channel. So I'll be sending you the link of the YouTube channel. So you guys can go to the YouTube channel and you guys can watch all these recordings. So whatever our daily recordings, daily class recordings, I perform, I'll upload it into a YouTube channel, and you guys can watch, and you guys can take a reference from there. And in our online in our training daily training session, we'll have some hands-on. We'll do some hands-on demo, like creating the pipelines, deploying some simple software, a simple software application. So that will do it hands-on. So even that hands-on demo, I'll upload it onto my YouTube channel. You guys can go ahead and watch this. So these are the tools. Jenkins is a continuous integration tool, which is mainly used for building your code, and you can also use it for testing creating your test cases and pushing the code to staging and production. And Docker is a containerization tool. It eases configuration management. It controls issues and scaling by allowing the containers to move from one place to another. It is, in the sense, it's like it will easily move from your different environments, from dev environment to a test environment, from test environment to a staging environment, and from staging to production. So Ansible is a configuration management tool. Mainly, it is a tool which is similar to Puppet and Chef. These are the continuous deployment tools. So Ansible acts as a master and slave model. So it has a master node, and it has different slave nodes. Slave nodes, in the sense, you can assume it as a worker node. So all these nodes in the sense, all these are virtual machines. So you have master virtual machine, and you have all the worker virtual machines. So on those on the worker virtual machines, you can attach your servers, on-premise servers, and you can deploy your code onto those particular servers. Okay, next. Nagios. Nagios is it's a tool. It's a monitoring tool. Not only Nagios, like you have different tools like Watchdog, Datadog, Prometheus, Grafana. All these comes under the monitoring tools. And Console is a DNS management tool. So where you can create your DNS name, domain name of your company, so that you can, when you deploy your software, deliver your software to the end client, they will be using that URL. So instead of using an IP address, you mask that IP address onto a URL or a domain name service, and with the help of that domain name service, people will be able to view your application. And here are the cloud platforms. So the cloud platforms, the widely used cloud platforms right now is Azure, and Amazon Web Services. These two are the widely used cloud platforms right now. And you also have Pivotal Cloud Foundry, Google Cloud Platform, Azure, as I told you, Rackspace, and you have OpenStack. And while coming to virtualization platforms, you have VMware, VirtualBox, Vagrant, and you also, if you're using Amazon Web Services and Azure or Google Cloud, all these are already inbuilt in these cloud platforms. So you can use like Linux operation system in installation, and if you use Amazon Web Services, you can quickly kickstart EC2 machine or a virtual machine, uh, and you can perform your DevOps activities over there. So configuration management tool, these are the configuration management tools. So Puppet, Chef, Puppet, Ansible, and we'll be using Terraform. Terraform is used as an infrastructure as code. So in Terraform, what you do is you'll it's a template. Terraform is a template. In that template, you specify all your infrastructure or your resources that you want to include creating your architecture. So what are the how many virtual machines you want to use, or how many Kubernetes clusters you want to use, or how many you can create a virtual private cloud, you can create subnets, everything is being maintained and managed by Terraform in a single template. So all these are, so whatever the steps that I told you before, everything can be managed using Terraform and CloudFormation. So Amazon CloudFormation and Terraform is one and the same. So Amazon CloudFormation is being licensed by Amazon Web Services, and Terraform is being licensed by HashiCorp. And for test and integrations, you can use Gradle, you can use Maven, you can use Jenkins. Jenkins is an integration tool. And while coming to monitoring, alerting, training, and logging, you can use New Relic. You can use all these Blue, Medora. All these are like the third-party tools, but the mainly used tools are New Relic, ELK Stack, Cube Prometheus, Grafana, Datadog. So all these are the widely used. So all these tools are like it's not widely used, but it's not, these are not popular, that popular. So and next, coming to containerization. So containerization, you have Docker, you have RKT and LXC. So these are the containerization tools that are available in the market, and these are the process supervisors. This is the management of operating system services. So these are the tools that that's used for the process management. And so for a security purpose, like once you deploy your code, you need to maintain your code from security threats. So for to that, like some developers might be hard coding the passwords in their code. So that shouldn't be used as a practice, and that shouldn't be encouraged as a practice. So for that, you are not supposed to hard code any of your passwords or any of your secrets in the code. So for that, we have a separate tool or a separate space called a key vault, which will be used in Azure. So in Azure, you have an Azure key vault. In HashiCorp key vault. So key vault is a space where you store your secrets. So you can store all your secrets, and when you deploy it or when you build it, you create an authentication from your build pipeline to that key vault, the vault where you provision the secret. So it will pull those secrets from the vault and it will deploy. So Veracode is Veracode, Sonatype. These are the two mainly used security platforms. So this will scan your complete code, and depending upon the code, it will generate a percentage, or it will calculate a percentage of the security, how secure your code is. So in basically in releases, like some of the major companies, like if the code is 95% secure, that it has a score of 95% security, then only it will be then only that code will be approved for deployment into a production environment. If there is no security, or if there are any vulnerabilities in the code, it will again be reverted back. The, the release will be disapproved and it will be reverted back and to the developer to fix those vulnerabilities and again start from the process. So coming to orchestration, or orchestration tools you can use, like Kubernetes, you have Docker Swarm, you have HashiCorp Atlas, you have Apache, Mesos, Elastic Stack. In AWS, you have ELK stack, or you have container services, and in Amazon, you have Amazon ELK East, AWS Elastic Container Service, and Azure, you have Amazon. Sorry, in Azure, you have Azure Container Registry. So in AWS, we have ECR. ECR is nothing but Elastic Container Registry, or you can call it as Elastic Container Service. In Azure, you have Amazon Azure Container Registry. I'm sorry about that, those two wordings. So while coming to the deployment, you can use, as I told you earlier, you can use Puppet, Chef or Puppet for the deployment, and these are the logging tools. So this will record your logs of the software. So these tools will record the logs of the software. So for this, you can use Papertrail, Logstash, or you can use Grafana Logkey. Grafana Logkey is one of the mostly widely used logging tool. So you can use this, and for ticketing, or for ticketing, you can use Slack, you can use Jira tickets, you can use ServiceNow, chat. So for I think most of you are familiar with these ticketing tools. So like I think any one of you are familiar with these tools? Hello? Hello, guys.
Yeah, hello.
Yeah, Vijay. So I was just asking, like, any one of you are familiar? I just wanted to know, like, if any one of you are familiar with ticketing tools.
No, actually, I'm not.
So how are you assigned task? So how is a task assigned to you? So is it not in a ticket based form, or like how is it assigned?
Uh, Actually, here in our organization, the
Mhm.
work is going on developing its own ITSM tool. Right now, the tasks are assigned through the Azure boards.
Azure boards, okay. Yeah, Azure boards are also similar to these Jira tickets. So in Azure boards, like they'll create an epic for you, epic or tasks for you, right?
Yes, yes.
Okay. So Arun, are you familiar with any of these ticketing tools? Are you there, Arun? All right. I think it's on mute. So let's continue. So as I told you, like this is a complete flow which I told you. So I'm gonna speed up with these slides. So the developers are sitting and working on an application. So once the developer is pushed onto this version control, get repository, then it will kick off a Jenkins build, which will create a continuous testing. So here it is creating continuous tests using Selenium, and once that's done, it's been continuously deployed by uh, Ansible and Puppet. It's these two other configuration management tools which is widely used for deployment. And once so this continuous deployment process has been done simultaneously, it's been containerized and virtualized, and it's been deployed. Yep. So this process has been done continuously. So first it will be containerized, virtualized, and then it will be deployed. So once the deployment is complete, so the next phase is the monitoring phase. So it's been monitored by Nagios, and once the monitoring phase is complete, it will send a feedback again to a developer regarding any issues or any alerts to be generated by the monitoring Nagios. So okay, so now automation enablers. So continuous integration and continuous delivery. So you all know, like, so these are the terms of the process what we use. So continuous integration and continuous delivery is used for automating the pipelines, and you can monitor your dashboards. And all these slides, these are all something which I have really explained it to you in the beginning. So you can I'll upload these recording in the YouTube channel as I mentioned. So you can watch it from there. You can pause for a couple of minutes and you can read through all these. And now going for automation benefits. So the first one is faster lead times, more frequent releases. Like it's very fast if you automate the process. It's just like you click one single button and your code is completely deployed onto your servers and being delivered to your. So it's that simple. So it's much faster. It creates more frequent releases. So you can collaborate with your client, and you can have their feedbacks, and you can want to make any changes more frequently. So you can release them in different release versions. Okay, and it has less turbulent releases. So like before using DevOps, there was a process which would take a lot of time, and there would be a lot of glitches in the software release process. So now you can do it without any turbulence, and there would be very few errors, and you can deliver high quality of software into the security and risk mitigation, and you can also faster the recovery of your application if your application goes into an issue. So you have like blue-green deployment. So blue-green deployment, I will explain you in the next upcoming classes. So blue-green deployment is like, so once one deployment is down, then you can rise up another deployment, or you can roll back the deployment. So that enables the faster recovery, business and customer satisfaction. So by all these ensuring all these practices, your customer and the business or your client will be much more satisfied, and you can have a very good software application. So So these are the automation gives route tasks to computers and allow people to solve problems, make decisions, and all this. And so these are already explained to all of you. So you guys can go ahead and review all the slides. So I'll upload anyhow. I'll upload all these recordings in YouTube. So you guys can take a look from there. All right. And now it's a Q&A session. So anyone have any questions or you guys can go ahead.
No questions from my side.
So did you understand did you get some basic understanding of what DevOps is or what is the process of DevOps?
Yes, yes, I clearly understand what is the process of the.
Okay. So any suggestions or any feedback for me how it was going? So am I too fast or you want me to go a little slow or any feedback
No,
or any
your pace is pretty much good. Not fast, not too slow.
Okay. Thank you, Abhijit. And any others have any questions? Arun or Pankaj? Hey, Linto, I can see you.
I think it's a long process.
Yes, of course, it's a long process, and it's not like you can just learn it in like one day or two days, or you can just learn it in overnight.
My question is, if you can study for all things, like Git, Jenkins, everything, all applications to study after will to continue the process. Or otherwise, it's only for the basic knowledge.
So today's introduction class, it will just give you a basic understanding of what DevOps is, and from next upcoming classes, I'll go hands on, so you guys can practice along with me, or once I have this recording uploaded in the YouTube, you guys can follow the refer from this YouTube video, and you guys can practice. Or if you have any questions, or if you are stuck somewhere, you guys can message me in our group chat. I'll be available to help you out with those issues. Or in the next, or if I still can't able to fix it, we'll have a class next day. So in that class we'll discuss about it. So
Okay.
Uh,
Which plan?
so basically,
Okay.
so basically, to completely learn DevOps, at least it takes like 3 to 4 months.
Okay. Which platform you are prefer? It's Azure or AWS? Which platform you are going to prefer
So
for
I'm
better studying?
so so what I'll do is to help you guys, if I take a small task, I'll try to deploy on all the 3 cloud platforms. One is Azure, AWS, and Google Cloud. So that you all will have a basic understanding on basic understanding of all the cloud platforms, like how it works. So at the time of your interview, at the time of your job change or job transfer, since you have this basic understanding, it will be much more easier for you to transfer.
Okay. Okay, thank you.
Yeah. And Abhijit, your question?
yes, yes. Actually, I have one question in my mind that in the entire process of this DevOps, there are so many tools. So is will only the single person is responsible for all the tools, or you have separate guys for every tool?
So Abhijit, in different organizations will not be using all these tools. So these tools which I have told you, these are only for our understanding. So each organization, if for example, in your organization, you said that they are using DevOps and Jenkins. So they may not be using all these tools. So it depends upon the organization, and as a DevOps engineer, we are all responsible to use these tools. So the developers won't use these tools, not the operation team will use this tool to automate the process. So we as a DevOps engineer, we will be responsible and will use most of these tools. So that's why as a DevOps training, I'm trying to explain you or cover most of the tools, so that you all will have a basic understanding.
Okay. Okay.
Okay. And any questions, Pankaj? Or Omji? Or Arun, any questions? Or Robin?
No, brother, nothing.
No questions from my end. Yeah.
No questions. So did you understand or did you go through the flow, Arun?
Yes.
Okay. All right, guys. So let's meet up tomorrow. And tomorrow, what we'll do is we'll start out with a version control tool, GitHub. So we'll have a complete understanding on GitHub.
Hello.
Yeah, Robin.
Brother, I have one request. Kindly share that recorded V section.
Yeah.
Because
I already told. So what I'll do is I'll share this. I'll upload this recording session in my YouTube channel. So I'll share the channel with you all guys in the chat. So
Okay.
you guys can just go to the YouTube channel link, and you guys can take a look from there.
Okay, brother. Thank you.
Okay.
Sorry, what you told?
I'm saying this recorded session, I'll upload it in my YouTube channel. So I'll share the channel link with all of you guys. So you guys can refer this YouTube video, or you can just practice it from in your free time, going to that YouTube channel.
Okay, so please share the link so that it will be easy for us to,
Sure.
Yeah, thank you.
Yeah. Any questions, Omji, so far? Did you understand did you get a basic understanding of this?
Yeah, overview I understood. Thank you so much.
All right.
It was very helpful.
All right. Okay. All right. Thank you, guys. So I'm ending this meeting right now. So I'll upload it. Once I'll upload it, I'll let you all guys know in the chat. Okay. Thank you. See you tomorrow, guys.
Okay, thanks. Thank you. Thank you.
Okay, thank you.
All right, bye.
Thank you for good better.
Thank you.